and then there will be some mentions about the courses that you can pursue. So today's agenda is something like this. First, we'll be discussing what is MATLAB and why it is important. And then I will be giving you an overview of the MATLAB software, different toolboxes it provides.
You're not able to see the presentation, Shahnawaz bhai. You're seeing the MATLAB window.
Okay.
Okay, now we can see this presentation.
Okay, let's start over again. Today's session we will be having on MATLAB. It's all about MATLAB and the concepts behind it, the career opportunities it provides, and the courses that are available from where we can learn it. Okay. So this is today's agenda. We'll be learning about what is MATLAB and why it is important. I will be showing you the software, a tour of the software, MATLAB software, the different toolboxes it provides, and how MATLAB online is important. And then some hands-on where we'll be learning about the basics of arrays and matrices, some plotting and visualization. Lastly, we'll be having a question answer session. Okay. So, yeah. So what is a MATLAB? It actually, it's a short form for Matrix Laboratory. So why has it been named like this? Matrix is basically a 2D array. Okay. Let me show you how it looks like. Many of you might be knowing what is an array. It's actually a data structure where we store some data. It may be a 1D array or 2D array or 3D array. So let's see. Can you see my MATLAB software open? Safbhai?
No, we are seeing the presentation.
Oh, okay. So here, we can open. The help section. Yeah, show this. Can you see the software?
Yes, we can see it.
Okay. So now this is from the help section, and you can see on the left pane, there's different categories are there. We go to MATLAB. From there, you can go to language fundamentals. Here we find matrices and arrays. Go here and see this A. A is a 1/4 array where we store 4 elements, 12, 62, 93, -8. This is a 1D array. Okay. Now this A is a 2D array, 12, 62, 93, 8. It's an arrangement of rows and columns, a 2D array. 2 rows and 2 columns. It can be of any size, 2 by 3, 4 by 3, 4 by 4, like that. And there are multi-dimensional arrays also. You can see here, this one. This is a 2D array, and like this, we have 3. Okay, so now you must have understood what is an array. So let's now move on to presentation. So what is a MATLAB software? It's actually a proprietary software for scientific computing. For what is scientific computing? Scientific computing is computing where we have large amount of data, where we need to multiply matrices, divide matrices, one matrix by another matrix. Okay, this is
Shahnawaz bhai,
scientific computing.
have you
Yeah.
shifted to the presentation? We are not seeing that.
Okay. You're not seeing that. Okay.
Just make sure that that is visible, whatever you are presenting.
Okay. Okay. Yeah. So um, it provides 3 basic facilities. The first one is maths. We can do lots of maths over here. Then after doing maths, what we need to do? We need to visualize each and everything. When we do maths, it's of no use when we are unable to visualize those maths. And how do we do that? We do all that using programming or coding, what we use in general language. And it's a platform that is being used by lots of engineers and scientists in academia and industry to analyze data, to write your own algorithms and create your different models. One example, I would show you my recent research paper that I have done using MATLAB. Can you see the web browser?
No, we are seeing the presentation.
Oh, you're seeing the presentation. Okay. Now you can see this. This is my research paper that I have done. during my research. Okay, so what I told, that we analyze data, we write algorithms, we do coding, we visualize the data. So here, this is my paper where I generated synthetic data of multiple sinusoids. This equation number one, it represents my data, which is represented by equation here. Xn is equal to this. This has p number of sinusoids. If you are familiar with signal processing, some of you might be familiar with signal processing. So if you are not aware, then do not get worried. It is just a signal model, okay, where we generate data. It's just a simple data, okay. And then we visualize this by creating this plot, a 3D plot. This is the visualization part. This was earlier, it was data generation part. And the data was mixed with noise, and it is being visualized by a 3D plot, okay. Then I developed two algorithms. This one, the proposed solution, uh, when the signal was mixed with noise, it lost its means actual features. So to recollect those features like amplitude and frequency, I have written this algorithm. So this is the algorithm development part. Okay. So here you can see computer simulation results. I have done it in MATLAB 2019 B version using the high performance computing facility, supercomputing facility at BIT Mesra. And you can see it is having 8 cores. Intel Xeon processor. It is actually a multi-core processor, CPU processor. It is not having GPU processor. Okay, 64 GB of RAM, and this is my work. And finally, I analyze data. After visualizing the data, I analyze the results that I got from my algorithm. These are the results, these plots, figure number 3, 4, 5, 6. So this is, everything has been done using MATLAB. So this is just a simple example. So now let's move on to presentation part. Yeah, okay. So what are its distinctive features? The first one is that it is professionally built. It is completely documented. Everything has been documented. All the pre-built functions, the toolboxes, how you can use a particular toolbox, how to start doing programming or coding in MATLAB, everything. And everything has been tested rigorously by the engineers working in MathWorks. It is a proprietary software developed by MathWorks Inc. Okay, it has also got some interactive apps, not some, but many interactive apps where you can test different algorithms on your data. You can have any type of data. Okay, some may have got financial data. Someone may have signal processing data. Okay, signal data. And then interactive apps are very easy to use, and you don't need to have much knowledge of coding. Okay, you can once you test your algorithms on your data, and then you get some satisfying results, then you can automatically generate MATLAB codes for your reproduction or automation later on. Okay. Third feature is scalability. Suppose you have large amount of data, and the computational complexity of your algorithm is very high. Okay, then your personal PC might not be sufficient for running those codes or analyzing those data. Okay, for that you need to run your analyses on clusters of computers or GPUs and cloud, and that can be done with some minor changes in your code, not lots of changes that you will have to learn a lot, and then only you can scale your algorithms and programs. Not like that. And you need not to learn big data programming. This is a huge facility provided by MATLAB. So what are its capabilities that we can do? I already told about data analysis, then graphics, visualization, programming, coding. You can build your own apps, okay, for deployment, for sharing with others, for selling to your clients. It is having external language interfaces also, from MATLAB to Python. Someone might be familiar with Python or all these languages, C, C++. So all these languages you can interface through MATLAB. You can call a Python library from MATLAB, or you can call also MATLAB from Python. This exchange can happen. Okay, hardware interfacing. You can program hardware like Arduino, Raspberry Pi. You must have heard these names earlier. You can code these hardwares using MATLAB. Then parallel computing for scalability. I just told you is about scalability. So parallel computing you can use. It MATLAB provides two toolboxes: parallel server toolbox and parallel computing toolbox for parallel computing. I will going in more detail on all these topics. Okay, and then you can write your programs and then deploy them on web or desktop. Okay, then you can use MATLAB Cloud for scaling your programs. Okay, let's move on to MATLAB website. There we are having a huge amount of information regarding all these things. Here, here you can see uh, all the points that I told: data analysis, graphics, programming, app building, and all these things. So let's go through them one by one. So what is data analysis? It helps us to organize. MATLAB helps us to organize, clean your data. The data we collect. If you are not familiar with this process of data processing, then you will be knowing when you start doing this that the data might not be clean all the times. Okay, you need to clean that. You need to organize those data, and then only you will be able to analyze those complex data sets. And we can use these analyses uh, for data from various diverse fields, from like climatology, predictive maintenance, medical research, finance, etc. Then uh, MATLAB provides thousands of pre-built functions for statistical analysis, machine learning, and signal processing. Okay, and other things I have already told you, like big data and scalability and visualization, all those things. So let's move on to graphics. Here we get more lots of details about uh, graphics. So how it helps? Here you can see this GIF on the right side. It shows us the types of graphs that you can plot using MATLAB. Lots of plots: surface plots, 3D plots, 2D plots, volume plots. Okay, and what is I also wanted to show you one more thing here, that everywhere you will find these links where you can learn more about all these topics. Okay, MATLAB plot gallery. So there is a little use of other MATLAB courses. You need not enroll for MATLAB courses if you just want to learn, until unless you need some verified certificate. If you need some verification, you can make your profiles on LinkedIn. There you have some assessment tests. You can take those tests after learning these things. Okay, there like I will show you my profile, LinkedIn profile. Okay. Here you can see my profile. This one. Here you can see these are my skills, and you can see that under MATLAB, you can see that past LinkedIn skill assessment. I appeared for the LinkedIn free skill assessment test, passed it, and then you will see this something like this over here. So for this is for online uh, skill assessment. Okay, you can take this one, and this will be your verified achievement. So now here you can see how many types of plots are there. You can do animation, launch. You can launch examples where you can see the codes, how these plots have been generated. Okay, these are the contour plots, three-dimensional, two-dimensional, data distribution plots, pie charts, okay, histograms, and all these things. You can just go on exploring. These are image plots, these are line plots. Okay, I just wanted to show you how it works. You can explore all these things. Then you can explore and annotate your visualizations on the graph. Like you can, here you can see on the GIF, it is showing how it is putting the x-axis label, petal length, and then the y-axis label, sepal length. Okay, here you can find more information on formatting, annotating, interacting with graphs, modify graph figures interactively. Suppose in case you don't find any pre-built functions for generating the plots, you can customize your graphics. And how to customize graphs, you can learn from here. Customizing graphic objects, developing chart classes. Okay, so this was about one more thing, you can also export your data plots. Okay, the plots you generate. It is as I already I have shown you on my research paper that I have used the plots in my paper. Okay, those are PDFs, PNG files, EPS files. Okay, you can export from MATLAB figure directly to these files, and you can control uh, the resolution also, the file types, okay, all those things. You can get the more information here, printing and saving, okay. This is important if you are doing research and if you want to present the things. Next, we move to programming. Programming is very simple in MATLAB. Just you can start, anyone can start just from day one. No need to, I will show you how. So I will not stress more on here. I will give you some examples found on during the last section. Okay, here you can see it finds the square root of 42. Okay, this is a matrix A. How is it created? Okay, inbuilt functions are there to find the eigenvalues of A, and different data types are provided for scientific computing, like numeric, string, date, time, categorical structures, and tables, etc., to represent your data. This is your data. Okay. Again, here you are having a good amount of tutorials. MATLAB on-ramp, you can just, if you want to get started, you can go through this free MATLAB on-ramp course. Here you can see get started quickly with the basics of MATLAB. This is free, and you can explore other courses also related to Simulink, AI, ML, math, image processing, signal processing, etc. Okay, I will be doing some hands-on MATLAB last section. Then you can build your own apps. You can see here using two tools are there, MATLAB compiler and Simulink compiler. Using these two tools, you can create your own apps for distributing. Okay, here you can see building your own app. One tool is there, app designer tool. Okay, how you can start this tool? Just type app designer in the command line. I will show you how. Okay. Here, if you type app designer, this is command line, command window, and I'm working on command line. App designer, enter. A window will open. Just select the blank app, and here you will see you can design the user experience, user interface, UI. Okay. Then you can okay, further. Yeah, here you can see. So in the designer view mode, here you can see, here you can design the user interface. Okay, user interface in the design view. And if you want to define your app behavior, you can do it in code view. Here, this one is the design view, and this one is the code view. Here you can see. Okay. So this is a broad topic, and I'm just giving you an overview. Okay. You can define the app behavior using also using state flowchart, a toolbox provided by the MATLAB. One more thing, if you want to automatically check your codes, another toolbox is there, code analyzer. You can use that toolbox also. You will not be using right now. When you become somewhat more experienced, then external language interfaces. Okay. See, calling MATLAB from another language. You can call MATLAB functions from another language if this is your coding environment like Python or C, C++, Java, etc. You can call MATLAB from your environment. You can call other codes, Python codes from MATLAB. All the details are provided over here, how to do that. Each and everything is given. You can also generate C and C++ codes. Suppose you write a MATLAB code, and if you don't know how to write C and C++ code, you can directly convert your MATLAB code to C and C++ code using the MATLAB coder tool provided by the MATLAB. Okay. So how is it useful? Why to convert your MATLAB code to C and C++? Sometimes we need to write programs we need to program the hardwares. Okay, at that time, MATLAB code can't be used for that purpose. For that purpose, C and C++ codes are used. So that's why MATLAB provides that feature. Okay, and if you we have another toolbox called Embedded Coder. Okay, Embedded Coder provides the complete support. Here you can see, okay, Embedded Coder offers built-in support for all the software standards. If you might be knowing, or if you don't know, you will be knowing later on that these are the software standards: AUTOSAR, MISRA-C, and ASAP2. Okay, it is compatible with all these standards. So, yeah. All these things, you can see that these are the processes of writing the codes. Okay, here you can see configuring get started. These are the sections: configuring for code generation, selecting targets. Targets are the hardwares like Arduino or Raspberry or Lego Mindstorm. Okay, these are the hardwares, or some signal processor, FPGAs, all those things. You can program all those hardwares. Okay, here you can also find or see how the companies are generating production code with embedded coder for controls, for signal processing, image processing, and computer vision, machine learning. All the examples are given over here. Okay, you will be able to get first-hand experience of how the companies are working using, how they are using MATLAB. Okay, these are all the examples. So this was about hardware interfacing. Yeah, here are the list. Here's the list of all the hardwares: ARM, Arduino, Intel, National Instruments, Raspberry Pi, Xilinx, Android, ST Microelectronics, Keysight. All the hardwares are supported, provided by these. Okay, and you can collect data using MATLAB also. Like I showed you my recent research paper, there I generated synthetic data using MATLAB codes. Okay, sinusoids and then added noise. But you can also acquire data means from sensors, like that is called live data streaming to and from hardware. You can connect your hardware, and that hardware might be having some sensors for data acquisition like audio and video. Okay, so you can connect those hardwares to MATLAB on your PC and then collect data directly from those hardwares. Okay, here are all the examples are given. What for image acquisition, if video acquisition, you can use your own PC's webcam. Then one Microsoft Kinect sensor is there for depth. That is called depth cam. Okay, that is also supported by MATLAB. This National Instrument DAQMX, that is also supported for data acquisition by data acquisition toolbox. Okay, you can connect your FPGAs to MATLAB for programming. Here some more examples are given, and then as I already told you, that you can automatically generate your C codes, HDL codes, or PLC codes. You might have heard the word PLC, programmable logic control. Okay, hardware description language. All these codes can be generated from MATLAB. Okay, and then you can use those programs for your for programming your microprocessors, FPGAs, and more. Okay, so here you can start working on your projects by acquiring some by buying some hardwares, and then just to start building. Okay, here lots of examples are given for controls, for robotics, mechatronics. For robotics, most people are interested in robotics and mechatronics. Arduino example is given. Lego Mindstorms is given. Okay, image processing, computer vision, your webcam, Raspberry Pi, Kinect for Windows. Okay, digital signal processing can also be done. Communication systems can also be realized using Raspberry Pi. Okay, computer science uh, projects can also be done using Lego and Arduino and all these things. Okay. Now let's move on to parallel computing. What is parallel computing? Uh, Suppose you might have seen that when you buy your laptops, your PCs, there we uh, get the configuration that it is quad core or dual core. What does that mean? It means that dual core is having two cores. That processor is having two cores. Quad core means four cores. Okay, so what is parallel processing? We distribute our jobs. Okay, whatever programming we are doing, uh, whatever work we are doing through our programs, we can divide those works or jobs uh, among those four processors if we are using quad core. Okay, so that is called parallel processing. I will show you how I used parallel processing in my programming. Okay. You can also use GPUs and computer clusters. Lots of computers are connected together. That is called a computer cluster. Okay. So in this way, you can use all your compute resources, in order to just speed up your computing. Okay. MATLAB provides high-level constructs. Some data structures are there that allow you to process a large amount of data without using big data techniques like Hadoop and all. Okay, that is a great thing. Okay, you can use NVIDIA GPUs directly from MATLAB, and for that you need not learn CUDA programming or MPI programming. You must have heard that you need to do some CUDA programming for using NVIDIA GPUs. For from MATLAB, you need not use those. You can directly use GPUs from MATLAB if you are having a GPU in your PCs. Okay. So here you can learn these two tutorials are there, how you can use parallel computing with MATLAB and Simulink. I will be telling about Simulink a little later. Okay, what is Simulink? Here you can see uh, how parallel computing works. This is a multi-core CPU. Suppose it's quad core, then four jobs are running over here. Then this is the GPU processing. Okay, all about, if you want to learn about how to do parallel processing, lots of tutorials are there. Okay, then you can also work on cloud. Okay, MATLAB also provides cloud services in association with Amazon Web Services, AWS. You can see here. And if you are a student and your college is having a campus-wide licensing, you can use online MATLAB, okay, for cloud processing. Okay, MathWorks Cloud Center, you can see over here. MathWorks Cloud Center starts MATLAB parallel server clusters on Amazon Web Services. It uses Amazon Web Services. There you can define how many cores you want to use, or GPUs you want. GPUs, what should be the memory of the GPU. that your program requires. Okay. Then web and desktop deployment. So when you write your MATLAB codes, how you will distribute it to your clients or to some other person who can use your programs. Okay. So if suppose one is not having a PC which can run MATLAB. MATLAB is a huge software and it requires a good amount of resources. So every PC cannot run the MATLAB software and MATLAB programs. So we need to create some standalone applications. That support is provided by MATLAB, and that is called deployment. For desktop deployment, for web deployment. Okay, you can create add-ins for Microsoft Excel. Software components can also be integrated into web. Okay, you might have seen how you can interact with some websites. Okay, you can put data over there and then it creates the plots. Okay, that is some kind of deployment, web deployment. Okay, and that can be done for a diverse range of industries and applications like semiconductor, electronics, manufacturing industries, okay, aerospace and defense industries, and for data science, financial services, image processing, signal processing. Okay, you can create apps and programs for deployment. Okay, so all the applications and components are encrypted. Whatever you create for deployment using MATLAB, all those will be encrypted. Okay, no one else can steal your property. That is called intellectual property. What you create is yours. Okay, that is encrypted by MATLAB, and that can be shared royalty free. You don't have to pay anything to MATLAB for sharing all those apps. Okay, and you can also maintain your ownership of your ideas, your algorithms and applications. Whatever you create, that will be yours. And I have already told about MATLAB Cloud. So just one more thing I want to tell, that MATLAB can also be integrated with online platforms like Jupyter Hub, Domino Data Lab, and Databricks. These three are some platforms, online platforms, where you can use MATLAB, okay, to take advantage of existing infrastructure. They have an existing infrastructure where you can run your programs. Okay. Now, this is all about how to take your research. Suppose you have done or created something, you have done some research, and then you want to take it to production. That facility is also provided by MATLAB. MATLAB code is production ready, so you can go directly to your cloud or and enterprise systems and integrate with data sources, data and business systems. Like you might have heard the names of Tableau and Power BI for data analytics. You can integrate directly to those existing systems. And then public clouds. These are public clouds: AWS, Microsoft Azure. You can also run your programs on Windows and Linux, both, even on Mac OS. Okay. Here you can see stable, scalable deployment. Now, second one is, I've also told you that you can run your codes on embedded devices like FPGAs, microprocessors like Arduino, Raspberry Pi, etc. And let's see. Yes, you can also generate, I've already told about C, C++, HDL code. You can also create CUDA code from MATLAB if you want. Okay. Now we come to one of the most important topic, model-based design. And what is that? So first, we must know about Simulink. What is Simulink? The best definition is given over here. Simulink is a block diagram environment. Here we use block diagrams for each and everything. Suppose you are using a signal analyzer, okay? Then that is represented by a block diagram, okay? So what are they used to? They are used to design systems with multi-domain models, simulate before moving to hardware, and deploy without writing code. You need not write code for deploying. You can just directly deploy, okay? And first, we simulate before moving to hardware. Uh, Directly doing everything on hardware might be very costly. So first, what we first simulate our model in MATLAB using Simulink, and then move it to our hardware. Okay. Here you can see this. Let's run this video. So you saw how it works. There are blocks for every means systems, okay? For blades of a wind turbine, the controller of the wind turbine, okay? Uh, the model for wind also. You can control each and everything. So this is about, this is the block diagram for model-based design, okay? You try out new ideas and you can test those ideas very fast. Okay, just you saw how the signals, how the efficiency can be improved by visualizing your uh, inputs and outputs of a wind turbine, of its motors, okay, of its blades, how the blades should change their directions. Okay, all those things can be controlled, can be designed using Simulink. That is model-based design. You can do all those things in uh, MATLAB Simulink. Okay, so here you can learn how to use model-based design with your projects. Okay, this is another tutorial. A look to the future with model-based design. Okay, then there are some examples for uh, model-based design, that is for agile software development. Okay, so for software development also it can be used. For systems engineering, it can also be used. Okay, for predictive maintenance, it can also be used. What is predictive maintenance? Predictive maintenance is, suppose in a company you are having lots of motors and different electrical equipments. Okay, so by as the time passes by, uh, they suffer some wear and tear. Okay, so that wear and tear is predicted. Okay, how long that motor will be running uh, accurately or properly, that is predicted using predictive maintenance. For that, predictive maintenance toolbox is provided by MATLAB. Then for software development operations, okay, development and maintenance. These all operations are also provided by uh, in this model done by model-based design. Okay. Here you can see lots of examples are there related to literature. Okay, how the customers are using customer success stories are given, how they used model-based design for what purpose, and how they successfully uh, how they were their design was successful. Okay, you can explore the solutions from here. So what else Simulink is for? Simulink is for simulation also. Here you can see an example. Okay, simulate. You can uh, create simulation for autonomous driving car. Okay, here you can do that. This is an example. So we can design and simulate a system before moving to hardware. How the controller that we have designed for autonomous driving, or whatever we design, we need to test that first. So we need to simulate. That simulation facility is provided by MATLAB. You can check whether your controller is working properly or not, and then you can move on to hardware. And then I already told that Simulink is for model-based systems engineering, agile software development, and you can create your own new blocks also. Optimize parameters. These things can also be done using MATLAB. Okay, so what are the different projects? Here you can find example of wireless communication project. Okay, here this is the diagram, block diagram. Okay, different blocks are there: transmitter, receiver, observer, amplifier, oscillator, antenna, and then you are visualizing your receiver data and the frequency spectrum. Okay, and then accordingly setting your goals or tuning your parameters. All these things can be done. Power system, power electronics control system, signal processing. For robotics also, you can see, you can use it. Okay. So here are some more applications. Okay. What can MATLAB be used for? For control systems. You might have heard about control systems. If you haven't, then I must tell you that control systems, suppose we are having a washing machine. Okay. The uh, the electronics that is present over there, that is controlled, uh, that controls the whole operation of a washing machine. Okay, that is called control system of that hardware, that embedded system. Okay, so we can design those control systems, test, implement, and control those systems. Okay, for machine learning, you might have heard about this signal processing, or deep learning, part of AI. Okay, predictive maintenance, robotics, image processing, computer vision, wireless communications, and lots of applications are there. You can go through all these. Okay, whatever your field of interest, you can explore. Okay. Okay. Now let's move on to. I must show you some about the MATLAB software. Okay. So this is how a MATLAB software looks look like. Mm. So how can we work over here? Here you can see home. Okay. Here we have got lots of options. Suppose you want to write something, you can write code from command line. Like I gave you an example of matrix. Okay, let's create a matrix A. Okay, how it can be created? Simple, like this. 1, 2, 3. 3 elements in the first row, semicolon, then 4, 5, 6. Okay, so this is 2 rows and 3 columns. 2 by 3 matrix is formed. Okay, 1, 2, 3 in the first row, 4, 5, 6 in the second row. Okay, when we give semicolon, it changes the row number. Okay, so this is called command line interface, CLI. And suppose you can go on writing commands here in the command window, but it also provides another feature called scripts. Okay, here, this, you can write this thing over here also, and you can write like I have written. You can see this example. Lots of commands are there. Okay, variable. These are uh, variable constants, constant declaration. Okay, then variable declaration, signal generation. Then using the algorithms to analyze those that signal. Okay, so lots of codes are written over here. Okay, for plotting the data. Okay, so for that purpose, scripts can be used. Just you run that script here. You go to home editor, sorry, and you can select the script that you want to run. Go to editor and then run. You can also press F5 for running the script. All the commands will be executed. Okay, so for command line interface is for short commands, small commands for testing, just how a particular command works, and then when you are well versed, then you can use scripts. Okay, this is my example of what code I used for my research, that the paper I showed you initially. Okay, I generated signal. I will show you how I had created this algorithm. I developed this algorithm, this algorithm of mine, and used in my for this analyzing this signal. So this is data analysis, and this is algorithm development. Okay, and then I will right now I will show you some examples. Uh, okay, first let me show you some toolboxes. Okay, then I will give you some hands-on. Okay, let's see. On the left pane, you might be seeing category. Okay, we are having lots of toolboxes provided. The first one is MATLAB. Okay, here the basics of MATLAB is given over here. You can learn from here also. Getting started very easy. Language fundamentals are given, how to do programming, how to import data and analyze them, how to use mathematics, linear algebra, differentiation, integration. Fourier transform is for spectrum analysis, uh, more generally used in signal processing. Then generative graphics. I already told you about the plots. Okay, programming, app building, software development. You can do software development. Here you can find under software development tools. Okay, external language interfaces. Okay, so now here you can see this is the 5G toolbox. If you want to work on 5G, this will be you will be using this toolbox. Okay, uh, if you want to go through just the functions of the 5G toolbox, here the whole collection of functions, inbuilt functions or pre-built functions, you can say, the whole list is given over here. Okay, and here everything about how to get started with 5G toolbox is given. Aerospace block set, aerospace toolbox, antenna toolbox. Okay, see how many things can be done using MATLAB. Computer vision, control system, okay, curve fitting in plotting. We sometimes need curve fitting. We have data and we need to fit some curve, a polynomial or something like that for to a data. That is called curve fitting. Data acquisition, how to acquire data from external sources. Okay, database, how to generate your database. Okay, deep learning toolbox, digital signal processing system toolbox, econometrics, whole lot of fuzzy logic toolbox. Now you can see that all the automatic washing machines you are seeing. Okay, automatic dishwashers, all those things are now being designed using fuzzy logic or fuzzy control. Then you can use this toolbox for designing those fuzzy control systems. Okay, then image processing, image acquisition. You can acquire image from external sources. Okay, like your webcam. MATLAB coder, I told you how to, it uses, it generates C and C++ code from MATLAB code. Okay, parallel computing toolbox. These are the very important toolboxes. There's the robotics toolbox. This version that I'm using is 2019B. In 2022B, you are having also radar toolbox. If anyone is interested in radar systems, they can get the new one. Okay, statistics and machine learning toolbox, all everything related to statistics, how to analyze the for analyzing data, statistics is very important. Okay, so here you have statistics and machine learning toolbox. Okay, so lots of toolboxes are there. Others are there that you won't be understanding right now if you are in bachelor's. If you are a researcher, then you'll be understanding. Okay, but let's not go into more detail. Just an overview, because lots of things are there. The most important one is this one, the MATLAB, how to get started with MATLAB. For this is for MATLAB coding, app building, okay, graphics. Now, here you can see application-wise toolboxes are classified. Okay, for maths, statistics, and optimization, what toolboxes are used given here. If you're interested in data science and deep learning, then these toolboxes are used. If you are interested in robotics, these 5 toolboxes are used, and so on. This is for application deployment. MATLAB compiler, MATLAB compiler SDK. Okay. Hardware support. These are the tutorials where you can learn how to use MATLAB and Simulink for hardwares. Okay. You can see the examples are given over here. Apps are also available. You can go through lots of examples. Is it visible to everyone?
Sorry, I'm not able to see. Only that code editor is visible here.
Coordinator. Okay. I showed the toolboxes. Could you see that?
No. Only the code editor window is there still after, I think, 10 minutes since.
Which window?
This code MATLAB R2019B. Yeah.
Okay. Then after that, now you can see this toolboxes.
Yeah, now it is visible.
Okay. So I was just telling about all these toolboxes over here. You might have heard.
Okay. Yeah, explanation I heard. But
so just you can see left side, left pane, category pane. Okay. Lots of toolboxes are there for lots of purposes. Okay. Signal processing, image processing, control systems, radar systems. Okay.
Yeah.
For antenna design also. Here
nice.
On the right side, you can see different types of applications. Suppose you want to work on data science and deep learning, then you can use all these toolboxes. Okay. If you want to work on robotics, then these toolboxes will be useful. Okay.
Fine.
That's why they have classified like this, so that if you are interested application wise, then you will have the toolboxes at one place. Okay.
Fine.
Okay. So this was about toolboxes. Now let's show you about MATLAB Online. Okay. This is MATLAB Online. Okay. Suppose you're not having a PC which can where you can install your MATLAB software, which is very heavy software. Okay. It requires lots of resources to run. Okay. So in that case, you can use MATLAB Online. MATLAB Online can be if you are in college. Sometimes colleges provide campus-wide licenses to run MATLABs. There you can get access to online MATLAB. Okay, you can just all the resources will be in cloud. Okay, you need not worry about your PC. So this is how it look like. Okay, the same that I showed you, the installed version of my 2019B. This is the recent version, 2022 A. Okay, and for running the programs, first you need to use the MATLAB drive. You need to upload your scripts. I already told you about scripts. Okay, so you need to upload your scripts for running your scripts. Okay, you can create your own folder. You can download the results that you get, the plots that you generate. You can download those. Okay, you can share your apps that you create uh, with others so that they can collaborate with you. Here you can use shared content. Okay, then many self-paced tutorials are there. Then MATLAB Cloud, how to use MATLAB in cloud in collaboration with AWS, Microsoft Azure. Okay, blob storage is also there. Hadoop distributed file system, etc. Okay, this is about MATLAB Online. So in MATLAB Online, if you use Amazon Web Services, you can also use their supercomputing facility, but you will have to take some subscription of that. Okay. Students can also buy MATLAB student suite version, where you get not all the toolboxes, but some toolboxes for 4,000 INR around, like that, if you want. But this is just for those if your PC is not capable of running MATLAB for them. And for those, it would be better if their college is providing access to MATLAB. Okay. So now this was about MATLAB Online. Let's do some hands-on. I will show you some examples of how to use, how to code in MATLAB. Okay. Now, can you see my MATLAB 2019B software open?
No, by the same MATLAB
Same.
R2019B. The
Yeah,
editor
yeah,
window,
yeah.
the matrix example.
Yeah,
Okay,
yeah.
okay.
Yeah,
Fine,
this
fine.
one I wanted to show. Okay. So let's now do some hands-on to get just how to code. Okay. I showed you how to write this matrix. Okay. We can generate some data. Let's do it for signal processing. Okay. Because let's generate a signal. Okay. A sinusoid signal. Here, what I'm doing is, let's show you what I'm doing. Okay. copy this code and run it in command line. Control V. Okay. So I'm generating an array of data, and that array is being stored in X. Okay, from 0 to 20, and I'm taking its transpose. Yeah, let's do it for without transpose first. See. So it's an array of data from 0 to 20. How we write? 0, colon, 20. It means by default, it will take step of 1. You can also define your steps from suppose 0 to 1 with steps of 0.01. Then you will have to write x equal to 0, 0.1, 1, like this. Okay. Semicolon to suppress the output in the command line. Okay. See. Here X is generated. On the left side, you can see the variables created. This is called workspace. This is called command window. This is called workspace. And the upper right one is called the editor window, where you have your scripts. Okay. Double click on X, and just besides your editor window, a variable window will open. There you can see that X is written over here. It is showing X variable. So X variable is what? It's an array of 1 by 11 double. Double means what? This floating point value. Okay. 0.1, 0.2, 0.3, you can see up to, it goes to 1. Okay, 1 by 11 array. How many rows are there? 1 row and 11 columns are there. Okay. This is your X. So let's again change it to this 0 to 20. Okay. Now, when we write this code, let's see what happens. Signal, copy this code, paste it here, enter. Now you have on the left side a variable called signal. Double click, then you have this signal variable. Okay, you can see the data generated over here. So signal is the 1 by 21 array. This is the size of the array, signal array. So let's see how we can plot this. Okay, just a simple function, pre-built function is there. Plot for 2D line plot. X-axis is X, Y-axis we plot signal. Okay. Copy this code, paste here. This is the signal. Okay. So here you can see this is the plot. You can change lots of things over here. You can zoom in to see. Okay, zoom in, zoom out. You can move or pan your plot. Okay, you can see the data tips, which click here, and you can see the values of X and Y at this data point. Okay, this is called data tip. And then you can export this setup. Okay, what size you want this graph to be, you can mention over here what should be the width, what should be the height in centimeters or inches. Okay, rendering, what should be the resolution. Okay, you can give here 300 dpi or 600 dpi. The higher the dpi, the better the quality of your figures. Okay, the font size you can decide, the line size, line width you can decide. Okay, You can directly apply to figure or just export the figure and save it as .fig. It's a MATLAB file, or as .tiff or .png or .jpeg or .eps that are used in documents, okay, for research papers, etc. You can export these files. So this was just an example of how you can use MATLAB. Very simple. If I ran all these three codes in from command line, you can save this script, which is showing here untitled. You can save it somewhere, and then you can run it. All the three commands will be executed simultaneously, and the plot will be generated. Okay. So I have told you about arrays, matrices, okay? And these arrays and matrices are very important in MATLAB. You will be using everywhere. Means maths is, and if you are using MATLAB, it is all about matrices and arrays and plottings. Okay, you can also search here in the search bar over here, plot. You just type plot and you can see plot results are there. Different types of plots. This is the 2D line plot. Okay, how to change the color of your lines. Okay. How to change the types of your lines, continuous line or dashed line or dotted line. Okay. You can also use some markers, as you can see. The details are given below. Here, different types of graphs you can plot. Here you can see what type of markers you can use, the colors of lines you can use, you can mention. Okay. How to write those things. Show you an example. Let's see this example. Okay. X-axis we plot X, Y-axis we plot Y1, and we want this X versus Y1 to be green. Okay, you can see this plot. This is green. X versus Y2, blue line, blue dashed line with markers. This circle markers. Okay. The third plot is X versus Y3 with cyan color and this marker of asterisk. Okay, this way you can write. So this was about plotting. For arrays and matrices, if you want to explore more, you can go here. And you see this this help section that I'm showing, is it visible to you? Or
Yes, it's visible.
okay. So here you can explore more about arrays and matrices. Okay. What is a diagonal matrix? How to write a diagonal matrix? Just mention A and the diagonal elements 12, 62, 93, minus 8. 4 elements are there, and you write just B is equal to diag A. It creates a 4 by 4 matrix because you provided 4 elements, okay, and the diagonal matrix is a square matrix, so it creates a 4 by 4 matrix with diagonal elements non-zero and other elements are 0. You can concatenate matrices, okay. If you use the function pre-built function once 1, 4, it creates 1 by 4 array of size 1 by 4, okay, 1 1 1 1. And if you write zeros 1, 4, then 1 row and 4 columns 0 0 0 0 0. And if you want to concatenate row wise, then just write A space B under the third bracket, okay. It will just concatenate in the row, single row. If you want to change the row, just write A semicolon B, okay, like this you can do. I told you how to generate the numeric sequence. A is equal to 1 to 10. This is, okay, minus 2.5 to 2.5. In increments of 1, it will go, okay, from 0 to 10 in increments of 2, 0 to 4, 6, 8, 10, like this. Multi-dimensional arrays are also there, okay, and these are created like this, okay. This is the how to create those multi-dimensional matrices. We create 2D ones first, 2D matrices, and then write like this: A colon comma 1. This matrix, okay, A. So each 2D matrix is called a page, okay? So we first create the first page, then the second page, then the third page, like this. This is a multi-dimensional array, and this is also called tensor. If you work in ML or DL and working with TensorFlow and Python, you might be knowing about tensor. Tensor is nothing but multi-dimensional array or matrix. Okay, how we create? We first create the first page, a 2-dimensional array like this: B colon 1, B colon 2, B colon 3. So it has 3 pages like this. Then there are lots of things for means higher research. If you want to go, then you will be using all these things. Okay. Everything is given. If you want to explore, you can explore. These are vast topics. So this was my presentation. Now, I think, can we move on to question and answer session? I think it's enough for today.
Thanks a lot, Shahnawaz bhai. So are there any questions?
Okay. One more thing. I want to tell what are the job prospects. Okay, I forgot to see. This is for data science. Okay, this graph is there. You can see on the left side, different languages are there. Can you see this screen of mine? Okay, so you can see the MATLAB first means this plot data is, I think, from 2019, but still it shows the trend. Okay, MATLAB, you can see here, MATLAB is there. And highest is Python, then SQL, Java, and C, C++, Hadoop, W, and here it comes MATLAB. This is for data science actually. In data science, the use of MATLAB is less, AIML. The Python and R, those things are used extensively. But as soon as you move into some engineering profession like electronics, electrical, and all those things, then MATLAB is extensively used, and it is very much preferred in academics and industrial research. Okay, uh, uh, the scientists all over the world, they are using MATLAB extensively for their research. If you want to pursue your research PhD in core fields like electrical electronics, then MATLAB is means you can't avoid MATLAB. And one more thing, some job requirements I must show you. They how they need it. Here you can see in LinkedIn, this is the requirement for signal processing algorithm developer at Skyroot Aerospace, a good company. Okay, they are working on radar signal processing, and you can see skills required: hands-on experience with MATLAB and Simulink modeling. Okay, you can see the first requirement, skill requirement is MATLAB and Simulink. Similarly, this is for data scientist intern at Amazon. Here also you can see the basic qualification. It requires masters, okay, but experience on R, SAS, MATLAB, and SQL. Okay, MATLAB is also important over here. Then another, it's a US-based company, Continental. It also requires radar algorithm engineer. Here you can see they need proficient in a scripting language. I just told you that you can create your scripts in MATLAB. Okay, so here they require MATLAB, and Octave is an open source and free version of MATLAB. You can download it freely from web. Okay, just search in Google Octave, Octave download. You can download it. It is almost like MATLAB. Not all the features are there, but still, if you want to use freely, then you can opt for Octave also.
That's great, man.
Yeah. One more thing I wanted to show you. Oh, yeah. If anyone is interested in radars, they can use the radar toolbox. Okay, I show you this. This here you can see lots of examples: automotive radar, multifunction radar, AI for radar, synthetic aperture radar. Just see how those companies, that company Continental that I told you that works on automotive radars, autonomous driving vehicles. Okay, you can see lots of examples are given over here. How to design automotive radar for autonomous vehicles. Okay, so these things I wanted to show you. Now let's move on to question and answer.
So do we have any questions from the audience?
I want to ask about autonomous vehicle simulation. You gave a glimpse of it. Is it like, what is the app or Simulink tool is used for simulation of autonomous vehicle?
Sorry, can you repeat your question?
Yeah, autonomous vehicles simulation.
Okay, okay.
Just gave a picture of it. So I want little bit more elaboration on that.
Okay. Okay, I will give you. You can just visit the auto radar toolbox. It is not present in my 2019B that I've installed, but MATLAB Online that I'm using, 2022A, there we have radar toolbox. You can see. Can you see the left pane category? Categories, different categories.
Yeah.
Yeah, this is, you can see the radar toolbox. You can use that toolbox. It's a documentation for means everything radar. Okay, anything you want to learn about how to design a radar in MATLAB, then you can go to the help section of the MATLAB. You can, I show you here in this pane, you can see upper right, this question mark. Okay, click that one. Then you will get this documentation help center. You will move to help center. Okay, there you can see on the left pane, lots of toolboxes are given there. One of the toolboxes is radar toolbox. You can use that toolbox to learn how to design different types of radars, okay, using this toolbox in MATLAB. You can simulate how I showed you how to how we use Simulink for simulating an autonomous driving vehicle. I gave an example initially. That can be done. Those examples are also given over here. Okay, getting started. These are the basics of the radar toolbox. Okay, tutorials are given over here. Modeling radar detectability factors. What are the detectability factors? How the radar signals propagate and how to model them. Okay, what are the how to model the target radar cross section. Suppose a target is approaching, how to model the cross section of that target. Okay, simulate scanning radar. How I told you how to means use Simulink for simulation. Okay, here an example of how to simulate a scanning radar. Okay, different types of radars are there, and lots of examples and tutorials are given over here. In applications, when you go, okay, you find different categories of automotive radars, multifunction radar, AI for radar, synthetic aperture radar. Okay, in whichever radar you are interested, you just explore that. Okay, if you are interested in automotive radar, see the examples, design and simulate an FMCW long range radar. Actually, FMCW radar is used for in autonomous driving. Okay, different types of radars are there. Ground penetrating radar, passive biostatic radar for military purposes. Okay. So all these examples are there. You will have to explore These topics are very vast. Okay, choose what you want to work on, what is your interest is on, and then start working. Okay. Anything else you want to know?
Thank you. Shukriya. Jazakallah.
Okay. Anyone else? Any question?
Okay, Shahnawaz bhai, I think
No
we are done
questions.
with the session. Yeah, no more questions. So
Okay.
thanks a lot, Shahnawaz
Thank you.
bhai, and to all the audience.
And yeah,
Shala,
thank you. Thank you
let's
for
meet up.
inviting me.
Yeah, we can have further detailed section inshallah later.
Thank you, everyone. Okay.
Okay, thank you. Goodbye.